In this subject, we are going to study about the probability. First, before starting to probability, we are going to have some definitions. Here, as you see, here we have experiment outcomes, sample space, and event, and simple event definitions we have. The experiment is an activity, has observable results, it says, and the experiment, like in the normal science lessons, the results how we are getting our experiments also same it's going to be. The outcomes, possible results of the experiment. So we are going to, when we roll the dice, let's say if the outcome is 1, this is the possible, or if the result is 1, it means that this is one of our outcome. And the sample space is the set of the all possible outcomes. Event is when you group of part or part of a sample space. Let's say you can divide, this is the sample space 1, 2, 3, 4, 5, 6, and you can get the event even numbers. What is the probability of even numbers? When you say 2, 4, 6 is our event set it's going to be. And simple events, each event here, there are 6 events for this one, and each event is called simple events. Okay. Here, what is the sample space of experiment of tossing a coin? If we have a coin, we have two different results. So sample space is going to be here head or tail. This is the sample space for the tossing coin. And by the way, here number of elements of the sample space is equal to 2. We have 2 events in the set. Here the events are head and tail, and if you get only head as an event, this is the simple event it's going to be, or this is simple event is going to be, or tail if you write, that's going to be also simple event. Okay, let's continue. What is the sample space for tossing a coin 3 times? 3 different coins, or one coin, if you toss 3 times, it means that you have the same result. So as I said before, tossing one coin 3 times or 3 different coins, they have same meaning. So here we are going to make the set of 3 coins. You know the results head and tail, it can be, but head, tail and tail. The first one is head, second one is tail, the third one is tail also it can be. So the sample space when I am writing head, tail, tail, head, tail, head, it can be head, head, tail, and head, head, and head it can be. So I changed from the beginning, let's say tail and from the end I changed tail and head, then I changed the second one, now I am changing the first one. So tail, head, tail it's going to be, and tail, head, head, and tail, head, tail, 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 and head, tail, tail, and tail is the last one it's going to be. As you see, we have 4 terms starts with head, 4 terms with tail, and as you see here, this side and this side, it's all similar. Here, if it starts with head, if it's here, if it starts with tail. Okay, so number of elements in the set sample space is equal to 8. By the way, By the way, we can find the number of elements in the sample space by using the box method. If you remember, the first time and the second time and the third time the tossed coin. Here there are two possible cases, here there are two possible cases, here there are two possible cases, so it's equal to 2 to the power of 3, which is equal to 8. It's going to be. So number of elements in the sample space we can find like this. Okay. The sample space for the experiment is this one. Write the event that result the prime number. So I'm going to choose the prime numbers. This is the sample space, so this is S, and I'm going to write the prime numbers. Which numbers are the prime numbers? I'm going to show the prime numbers with P, and the 2 it's going to be, and 3 is prime number, 3 is prime number, and 5 is prime number, and 7 is prime number, and 9 is not prime number because it is divisible by 3. So number of P is equal to 4 is going to be. Okay. Here we have the element, because later we are going to deal about the A or B, probability of A or B, A or A intersection B, or we are going to deal about not for the probability of not event. What does it mean? Let's say, if you remember, we were telling that what is the probability of the not probability, we were finding the permutations. What is the permutation of 7 and 8 together? Here 7 and 8 not together. When we say, if you remember, we are going to find the not case or A complement. It says here A union B. This shows this is A intersection B, and this is A not, as you understand from the shaded areas. Here there are two events and the results are 1, 2, 3, 4. Here 4, 5 and 6. If I write the set here, this is the sample space. In the sample space there are two events, and the first event has 1, 2, 3 and 4. In the second sample space we have 4, 5 and 6. As you see, 4 is common for both of them. That's why I put inside both sets. This is the set A and this is the set B. So it says, by the way, it says A intersection B is equal to what? A intersection B already we can understand from the set. A intersection B is equal to, A intersection B is equal to 4 is going to be, and A union B, the all the elements here 1, 2, 3, 4, 5, 6. 1 A union B is equal to, pardon, I should write here 1, 2, 3, 4, 5 and 6 it's going to be, and A naught. What is A naught? The which elements in A union B, which elements are not belongs to A. So these are only 5 and 6 it's going to be. By the way, there are no elements in the sample space different than elements of A or B. Okay. We are going to continue with the mutually exclusive events. Mutually exclusive events means there's no intersection. How there's no intersection in a case? Let me explain simply like this. In rolling the dice example, the result possible outcomes are 1, 2, 3, 4, 5 and 6 it's going to be. There are two events I can define. Event 1, it can be even numbers, 2, 4, 6 it can be, and event 2 can be odd numbers, and it can be equal to 1, 3 and 5. So if these two events, they are mutually exclusive events because they don't have any intersection. They don't have an intersection because if a number is even number, then it cannot be odd. So these two events, they are mutually exclusive events, they are called. Okay.